Alright, this video is going to be about how to combine like terms, or you might see this written as how to simplify expressions. And combining like terms is something that if you already know how to add, subtract, multiply, and divide, then good news, you already know how to do this. And combining like terms is something that you will use throughout all levels of math. So it's really useful. It's a foundational basic algebra skill that, believe it or not, is really not any different from basic adding, subtracting, multiplying, and dividing. The only thing is that the problems will look different because in algebra you start using variables like x and y instead of just numbers. Let's just look at a few examples here. Okay, so if you're watching this video, I'm sure you already know 2 plus 4 equals 6. Alright, but what if I wrote this a little bit differently? What if I wrote 2 times 1, the parentheses just means multiply, plus 4 times 1. And you might think, okay, well, why would you do that? Because 2 times 1 is just going to give me 2, and 4 times 1 is just going to give me 4. Well, that means I could also write 6 times 1 over here on the right. Okay, and this might seem a little pointless, but it does help me illustrate the fact that the 2 and the 4 both have a 1 kind of attached to them. It's implied, so if you wrote it there or you erased it, it doesn't change the problem at all. Okay, and in algebra, when you start using variables, you're going to treat variables just like this imaginary 1. Okay, so what I could have done easily is just written 2 with an x attached to it, plus 4 with an x attached to it, equals 6 with an x attached to it. Okay, so 2x plus 4x equals 6x. Alright, and that is combining like terms. That's really all it is. So it does get a little trickier. We'll see a few problems here. Let's look at number 2. We have 3x minus 9. And here I wrote the x's in green just to kind of set them apart. Okay, 3x minus 9. Well, the 3 has an x attached to it, and the 9 just has nothing, or our 1 we mentioned earlier. So really there's nothing you can do here. You can't combine x's and imaginary 1's. So the simplest this problem gets is 3x minus 9. Alright, let's scroll down. 3x minus 9x equals 4 plus 7x. Okay, and here we have an equation. We just have two things on opposite sides of an equal sign. And we're not going to solve it, but I did want to include one of these because this is a very useful thing to do when you start solving equations in algebra. Okay, so on the left side, we have a 3 with an x attached to it, and a 9 with an x attached to it. So what we can do is just combine those. So 3 minus 9 is going to give us a negative 6, and you have to write the x. The x has to come along. So negative 6x is what this left side would simplify to. All right, and then on the right side, we have a 4 plus 7x. I should have written that in green. Okay, and again, the 4, it just has the imaginary 1 attached to it, and the 7 has the x, so you cannot combine those. You just have to leave the 4 as a number and the 7 with the x on it. Okay, let's look at this one. We have 3 halves plus 4 halves. Okay, why would I include this? Well, when you combine like terms and you start having variables, I just wanted to point out that the variables do not change the fact that you're just doing the same rules that you've always used with fractions. So what do you do when you add fractions? Well, you get a common denominator first, and here we have a 2 on both of these on the bottom, so all we have to do is just add the top. 3 plus 4 equals 7 over 2. All right. Okay, so with this one, we have variables with fractions, and I wrote this 3 times just to show that when you have numbers being multiplied in fractions, you can write the numbers that are multiplied either on the top, or you can separate them out to the side, like I did here. And I could have also taken the 3 and left the x on top, and the 4 and the x on top, like this. All right, just something to keep in mind because you'll probably see this a lot. All right, so before, when we had the fractions we're adding that had common denominators, we just added the top, and now we know that 3x plus 4x is just going to be 7x over 2, and that's really all there is to this one. Now, the reason I wrote this here in the middle is because it makes it look a little bit closer to what we did before, where I said that it's a number with an x attached to it, and if you have 2 numbers with the same thing attached to them, you just add them together. Okay, so 3 plus 4 is going to give 7 over 2, and the x comes along. Okay, here we have radicals or square roots. All right, we have 3 roots of 2 plus 5 roots of 2. Okay, and this is very similar to what we did before. So in this case, the 3 has a square root of 2 attached to it. The 5 also has a square root of 2 attached to it. So all we do is just add the 3 and the 5, and that will give us 8 roots of 2. All right, and this one also has square roots, but you'll notice that the 3 has a square root of 9 attached to it, and the 2 has a square root of 6. Okay, so this is like our problem where we had an x attached to one number and an imaginary 1 attached to the other one. Okay, they're not the same. So the square root of 9 is not the same thing as the square root of 6. So you cannot just add the 3 and the 2. You could simplify this a little bit using properties of radicals, but we're not going to get into that in this video. So for now, we're going to say that this is the simplest that this gets. We cannot combine these terms. Okay, and here we have 2 variables. So we have an x and a y. Right, and this might look a little scary to you at first, but don't be intimidated by it. It's really the same problem. So we have 19 with an x and a y attached to it, and 12 with an x and a y attached to it. All right, and as long as we have the same thing attached to the numbers, we can just add those numbers, okay? So 19 plus 12 is going to give us 31, and the x and y have to come along. So 31xy. Okay, here we have variables being multiplied. Okay, so we know that 2 times 6 is just going to give us 12. But what about x times x? Okay, when you multiply a variable times itself, what happens is you raise it to a power. Okay, it gets an exponent. Now, x times x is not 2x. Okay, that would be x plus x. So what happens is the x times x becomes x squared. Okay, and we could, if it would help, to rewrite this like this, kind of separate the numbers and the variables, 2 times 6 and x times x. There are all kinds of ways that you can rearrange things in algebra that might simplify things or make it neater or easier to understand. All right, here we have fractions with variables again, and I just want to show that this is exactly the same as adding any other fraction. So we just need to get a common denominator. And I'm going to run through this a little bit quickly because I know this video is getting long. But this does make the point that variables are just numbers, so we're just going to treat them exactly the same. All right, so I'm going to rewrite my 1 over 2x plus 4 over 9x. And what are we missing on the left side? Well, we don't have a 9, so I'm going to multiply the left side by 9 over 9. and the right side by 2 over 2. Okay, 9 times 1 on the left is 9. 9 times 2x is 18x, plus 4 times 2 is 8. 9x times 2 is again 18x. Now we have common denominators. 9 plus 8 is going to give us 17 over 18x. All right, looking at our last one. Here again we have two variables and a fraction. All right, and the good thing about having variables and fractions is a lot of times you can cancel things, okay? So what I'm going to do here is separate this and kind of rewrite it. I'm going to write this as 3 over 2 times x over x times y over, there was nothing there, so you can write it as over 1. Okay, and here, hopefully that made it easier to see that we have x over x, right? And when you have any number over itself, that's just 1. So I'm going to cancel the x over x, and this becomes 3 over 2. I can rewrite this y over 1. Now, again, you have a choice as to how to write it. You can leave the y on the top and do 3y over 2, or you could do 3 halves y.